All right. Do you guys remember the formula for a slope way back when? Let's see here. Alrighty. Okay. Yeah, that's the one. So the idea and why we talked about limits in the first place, other than they're useful, but the main reason. So here are 2 points, right? Can you guys see this? See this okay, the graph? Okay. Sorry,
Yeah.
Yes.
my computer was telling me that wasn't showing, so thanks. So here's 2 points. Um, we can find the slope through those 2 points, right? Technically, we can do uh, oops, that's not quite right. Oh, that's kind of shitty, but anyway, you can see this line going through them. So if you were to do y2 minus y1 over x2 minus x1, find the intercepts, find all that stuff, find the equational line using those 2 points, you'd find this blue line that I just drew. Okay. You'd be going through both points. Now, what you do here, so the idea becomes like, well, what if I want to find a slope of 2 points infinitely close to each other? And this is where limits comes into place. Like, what if I chose like something really close to this point, right? Or like really, really close. All right. So if I pick 2 points right next to each other and do the slope formula, I should be able to get the slope right next to a point, a single point. So in essence, if I have a point somewhere, right? Let's say right there, and I wanted to know what's the equation of the line that's tangent to this point. If I had some random line, like just tangent to it. What is the slope of this line? So you figure out the slope by just assuming that the 2 points are so infinitely close that you'll equate you'll solve for the slope, which will be that slope right there, find the intercept, etc., just like we did back in the day, y equals mx plus b. But it's coming from the idea that we get x2 and x1 really close to each other. But there is a problem. I don't know if you guys see the problem. All right, let's do number, I don't know, pick one. Number 5, I guess, just to use the property a little easier. 3.1. The derivative and the tangent line problem. Okay. So the y2 minus y1 over x2 minus x1, you can see what happens if x2 and x1 are the same, right? Find the slope of a line connecting two points. We use m equal to y2 minus y1 over x2 minus x1. Does anyone see what the problem is if x1 and x2 are the same?
It would make it a 0 and thus make the slope 0.
Yeah, so if the point's the same, right, then you'd have division by 0. So the idea is, okay, well, what if I make them infinitely close? Then I can find the slope of a single point. Allow a line tangent to a single point instead of a line going through 2 points. So that's why that's where we're going with this idea. Right. We have 2 points, put them right next to each other, infinitely close to each other, and we can use limits to find the slope of any point. Okay. So you can kind of estimate right here, right? The slope of a line right next to this point, right there, is going to be 0, right? Because it's horizontal. Slope of this one is positive, going up and down, left to right. So increasing looks like maybe about 1, maybe a little more. But using limits, you can find out exactly what it is, which is what the derivative is going to do for you. So you find the derivative of a function, plug in a number, plug in a point, and you'll be able to get the um, exact slope. Does that make sense? The idea? Use the limit process to find the derivative of f of x equal to x squared plus x minus 8. All right. So this is notation. So if you see a function with a little quote on it, that means the first derivative. But if you see it written like this, d dx of a function, that means derivative of f. And in order to find it, we're going to use the limit. This formula here, the limit of the difference quotient. So see, as the denominator goes to 0, we're going to end up finding the derivative because we take the limit. We don't actually plug it in. Okay. So in order to find the derivative using the limit property, I recommend doing this in steps because you can see this looks kind of nasty. It's a lot of algebra. So step 1, find this part. Right, so f is this. So just plug in x plus h. So f of x plus h will be x plus h plus x plus h minus 8. So that will be, I have to square all this nonsense. So square this. Um, I'll do it down here. X squared plus 2xh plus h squared plus x plus h minus 8. There is the expansion. Okay. Step 2. subtract, do the numerator, basically take the result of this and subtract by f of x.
Did you put in x squared plus 2xh or
Plus a squared, yeah.
okay, thank you.
You guys cool with number step one? Okay, so let me know. So take this result, this is right there, subtract the original f. So that will be all this garbage. Oh, pencil's dying. Sorry, that's not. Okay. Okay, so take the original minus the, take the result of the on step one, subtracted by the original. Okay. So that'll be all the same stuff. Minus x squared minus x plus 8. Distribute your negative. So everything will cancel except 2xh plus h. Right? X squares will cancel. X is canceled. 8's are canceled. We're left with this one. And that guy. Okay. Yes, cool on step two. You can see there's a lot, there's just algebra stuff, but let me know if you don't see something.
What happened to the h squared? How did that cancel out?
You're right, it did not. So let's see here. Okay. Double check everything. Yeah, that should be a. Mhm. Yeah, I don't know what happened there, but thank you. All right. I'm gonna turn the page to step three. You guys cool so far? All right. Excuse me. Step three. This now the result from step two, just divide the whole thing by h. Oops. Say. Okay.
Are we just using the H for the delta X?
Pretty much, yeah.
Okay.
I don't like the delta X just because we have X's everywhere. It can get confusing, but it's the same thing. Okay. So the result was 2xh result was 2xh plus h squared plus h over h, right? Factor your h out. Now this is where it's supposed to cancel. If it doesn't, or you can't cancel it or factor it, then you probably did something wrong. At this point, just take the limit. So this will be, well, I don't need the division bar anymore. So when you plug in the derivative, you'll be left with, or I'm sorry, the limit, you're left with 2x plus 1. So f of x was originally x squared plus x minus 8. The derivative will be 2x plus 1. Is there any questions on step 3 or step 4?
Makes sense. Just a lot of writing.
Yeah, it's tedious, and I'm only going to make you do it once on the exam. The rest will be the shortcut way, more simple way. Okay, should say exam 2, not 1. No, excuse me. So it's going to be the same thing over and over again. The difficulty will vary depending on the function. Like this line, this let's see here. So number 5, on the derivative. Once you find the derivative, if they ask you for the slope of the tangent line, that all you got to do is plug in your x value into the f prime, the one I just found. So for number 3, number 2 and 3, you do what I just did, and then plug in x at the very end. So they only want a number. Okay. You should also know that the derivative of any constant is going to be 0 because there is no change. It's literally, it's in the name. It's constant. So if you were to do it with this one, it's going to be 0. This is a linear function, right? A line. So the slope of the tangent line is going to be the same thing as the slope of the line because it's just a line. If you graph this, it doesn't matter, right? The rate is the same across the whole thing because it's a line. On that other example up here, it wasn't a line, so the slopes depended on where you were, right? See how up here it's a little steeper, we're increasing. Here we're 0. Go down the slope, we're decreasing, right? Go back up, we're increasing. That makes sense. So if it's just a line, it's just this. But you can do the work if you want, and you're going to see what I'm talking about. Doesn't change. The harder ones are stuff like this. See how it's like a fraction? Those are kind of annoying. Let me do one of those so you can see. I mean, it's the exact same thing. It's just that you have to deal with fractions. I'm gonna do one of them because I know someone's gonna get stuck on this. And derivative of f, which is equal to, I'll choose this one. Okay. Using the limit process. The long way. Okay, step one. I'm gonna try to shorten up as much as I can where it makes sense. F of x plus h, well, that means plug it in. So that'll be 5 over. So right here where we have an x, plug in x plus h. Step 2. Subtract the original. This will be annoying because it's a fraction. And it's just how it is. Okay, so that will be this guy minus the original. You're going to have to do an LCD for rational functions. So these denominators are both prime. So since the denominators are prime, the LCD will simply be the product of those two. All right. So in order to make it look like this, multiply the first fraction by x minus 8 over x minus 8. Multiply the second fraction by the other denominator, which will be x plus h minus 8, x plus h minus 8. Okay. Do not actually multiply it all out because you want stuff to cancel and etc. Just leave the denominator alone. That's what I'm saying. We're gonna have to multiply the top, but now that we have the same LCD, right? We're gonna have 5 times x minus 8 over this garbage. Oops. Minus this one. I'll write them the same just so it's clear. So this one I'm just going to call this LCD because this is annoying to write. Okay. So distribute your 5x minus 40 minus all of these terms. I'm gonna leave it like this so you can see it a little better. Okay. Distribute your -5 and you'll get 5x minus 40 minus 5x minus 5h plus 40 over LCD. Just about done. So this will become 5x's cancel, 40's cancel. We're left with -5h over the LCD, which I'll just go ahead and write it this time. Okay. There, we subtracted the two fractions, the f of x plus h minus the f of x. Is there any fraction steps you don't remember because you're rusty, or any issues with the algebra here?
Oh, I see. You got 40 because it was -5 times -8.
Yeah. Yeah, distribute this here. Then distribute this. They gave me these three. And then you'll be left with this on top. Okay, that's step 2. I'm gonna turn the page. You guys cool?
No.
All right, what's bugging?
I'm still writing this down.
Okay, yeah, there's no rush.
And mine's virtually the same problem, but instead of 5 and 8, my numbers are 6 and 3, but pretty similar.
Yeah, I shouldn't change anything really, just same process.
I think I can already see the answer though, just looking at the problem.
Yeah. Yeah, it's pretty close, right? Yeah. Let's see. All right. You guys good?
It's saying it's wrong for me.
No, we're not done yet.
Oh. Okay. Yeah, you can go ahead. My bad.
Yeah, no, you're good. Well, we still gotta take the limit, right? We're going to step 3 though. This is why I chose this problem because it's long, and the algebra is annoying. All right, find. You gotta divide by h now. Okay, so basically we take our result, which was, I forgot. Dang it. Negative 5h over x minus h plus 8. What is it, minus 8? Minus 8. Times x minus 8. Now, dividing by h is the same as multiplying by 1 over h. You guys cool with that?
I believe it's x plus h minus 8.
Oh, is it plus? Oh, yeah, of course. Right there. All right, to save some time, I'm going to use this instead of division, right? Because it needs to be in the bottom, so there it is. Okay, so that'll be negative 5h over h. Just put it in the front. All right. So 4, just take the limit, but you can already see, right? These cancel. Find the limit of this difference quotient, which is the limit of this. So the limit of negative 5 over x plus h minus 8. Yeah, that should be fine. Take the limit, and you end up with negative 5 over x plus dang it. H will be zeroed out, so you'll be left with x minus 8 twice, right? Okay, finally. So this is my derivative. So the original function was some bunch of nonsense. Let's see. 5 over x minus 8. The derivative of that function will be negative 5 over x minus 8 squared. This is what they want, I think. I forgot what the question said. It was so long ago. Yeah, just find the derivative. This is this. Any questions on any of the steps?
So what's boxed is the answer?
Right. I think they have this already written, so this piece is what you type in.
Okay, thank you.
But yes. Okay, you guys cool on this example?
Yes.
All right. Let's see here. Find an equation of the tangent line to the graph of f at the given point. All right. So basically, we're going to redo what we just did. Find the derivative first. Yeah, pretty much. And then plug in the number. That'll give us the slope. Once you know the slope, use this point to find your y-intercept. And that's it. Okay. But let me graph this for you so you can see what we're talking about. Let me see. I'll use this one. All right. Okay, so there's my line, or my graph. We want to find the equation of the line that has a slope tangent to this point. So the equation of this line, what's what they want. Does that make sense what we're doing? The derivative will give us the slope of that blue line. That's what the derivative can do for us. It can do quite a few things, but that's what we're using it for right now. So what we'll have to do is find the derivative of f, plug in 19, that'll give us m. And then solve for your intercept using, y equals mx plus b, and then we're done. The most annoying part will be the derivative. All right, I'm going to turn the page. You guys cool on this one? No rush, of course. Okay. I believe that's number 8. Given f of x equal to square root of x minus 3 and 19 comma 4 part A. I'm going to make it more clear. Find the equation of the tangent line of f of x at this particular point. 19 comma 4. So basically use one of these. This is a thing from, was it middle school? I don't remember. Maybe high school. So I'm going to call m tangent the slope, m tan. Or you can use this point slope form is what it was called back then. You remember this? sure it was
Yeah.
it's the same concepts we've done before. The only thing is finding this m requires a derivative. We already have x1, y1, right there. So using this is no big deal. Getting the m tangent is the most annoying part because we're using the limit rule, which is the long way. Okay, so step one. Find the derivative of f of x. This time I'm going to do it all at once instead of doing it in 4 steps. Or, writing all those details. So basically we should know that f prime is equal to the limit as h goes to 0 of x plus h minus 3 minus x minus 3, right? Do you remember back from chapter 2 how we took these kind of limits? The square root should trigger an idea, I hope.
You would input the conjugate, right?
Yeah, we need the conjugate. So use the conjugate, do the algebra, see what cancels, and then oh, oops. I skipped a step. Too many steps. And then take the limit. Sorry about that. That's line 2 right there. Right, we're using this formula, which will be what I had a second ago. And then we do conjugate. Okay. Okay, so take this stuff here. And multiply by the conjugate on top and bottom. We're forcing a difference of squares to happen, because the difference of squares will square those roots for you. Okay. So multiply these together, we should see you're gonna end up with this. I'm gonna skip a minor step. If it bothers you, let me know. All right. The conjugate allows us to use the difference of squares on top, and you end up with this. I'm not gonna mess with the bottom, just leave it there. We mainly want this to happen. Excuse me. So you will end up with x plus h minus 3 minus x minus 3 over this nonsense. now you should see that this x will cancel with that x, this 3 will cancel with this 3. Once you distribute the minuses. Is that clear? You guys still with me on this question?
Yes, sir.
Okay. Thanks. Just let me know if it gets weird. So now we should only have an h over h times this stuff. That's these are gone. Finally, you can take the limit. Once you take the limit, you'll end up with 0 here. X minus root 3 plus x minus root 3 is just going to give us 1 over 2 of those x minus root 3s. Or root of x minus 3, rather. I skipped the step here because I'm out of space. Do you see how we got from here to here?
Yeah.
And it's just when you plug in the 0, you have the exact same thing, right? Root x minus 3 plus root x minus 3, so I have 2 of them. Anyway, all of that garbage for the derivative, which is this. And now we can find m tangent.
Okay, I'm lost. What happened to the h from like the square root of x plus h minus 3 from when you have the 1 over it?
Oh, from this from here to here.
Yes.
So when you take the limit, right, you finally let h go to 0. So when h is 0, do you agree that we're going to be left with x minus 3 in here?
Okay, I get it now.
Oh, you see it?
Yeah.
Okay, cool. We'll start step 2 in just a moment. Step 1 is find derivative. Which is this? Any questions on step 1? I'm going to turn the page in a moment. Step 2. Use f prime, which is the derivative, to find the slope of the tangent line, which we're calling m tangent. So m tangent is equal to derivative at 19, which is equal to 1 over 2 square root 19 minus 3, which will be 1 over, that looks weird. One over 2 times 4, which is 1 over 8. Okay. So we use the derivative by plugging that in what we found on the last page. So now, step 3. I recommend using this one. It's a little easier. The point slope form. So basically plug in m tangent equal to 1 over 8 and the point 19 comma 4. You're going to get y minus 4 equal to 1/8 times x minus 19. So solve for y and you'll have your equation that they're asking for of the tangent line. Distribute your 1/8, add the 4 over, you'll have 1/8 x minus 19 over 8 plus 4. Negative 19/8 plus 4, that would be what? Some nonsense. Sorry, I went blank for a second. Getting tired here. Negative 19 plus 32, that will be 13, right? So this guy. This is the equation of the tangent line.
Hey, sir, can you scoot the board up, please?
Oh, thank you.
Thank you.
So the process would be the same no matter what the question is. It's just that the algebra will be worse depending on the type of function you have. If it's a simple function, well, then this is much shorter. If it's a rational function or square root or something ugly, then it's gonna be long. Does that make sense?
Yeah, and you can replace the 1/8 with just x over 8. Make it simpler.
Yeah, that's fine.
Can you remind me how we got 32 over 8 again? I forgot how to do that.
Sure. So if you're adding these guys, and it's over 1, you gotta multiply by 8. So 8 over 8. Right? You get the LCD and then you add them together. That makes sense, or
Okay, that reminded me. Thank you.
okay, just making sure. If you need more details, let me know. Okay. But yeah, that's it. That's number 8. Let's do number 9. That'll be the last one for 3.1. Okay, you guys cool on this page? Oops, forgot about this. Dang it. That's hmm.
Will the second test also have the Desmos links so we can plug them in and see which graph is the correct one?
Oh yeah, I always try to add it, but sometimes it doesn't work. Did it work this last test?
Yeah, it worked.
It
Oh,
worked.
cool. I'm always worried about that. All right, let's take a 5-minute break so I can make space here. Give me one moment. All right, guys. Let's you erase a couple of pages there. The number 9 is find an equation. So this one's a little annoying. It's just well, it's just a strange question. It's what it is. It's not long though. Find an equation of the line parallel. We know it has one R. Parallel to the given line. All right. So this is the function they're giving us. This is a random line they gave us. Okay. So they want the equation of the tangent line. That is also parallel to this rando line. First of all, let's solve for y, because that'll just look strange, doesn't it? Yeah, that's better. Okay. What does it mean for two lines to be parallel? How can you prove that they are? Do you remember? So visually, you can kind of see it. Yeah, it has to have the same slope. So if they want the equation of the tangent line, that's parallel to this line. That means that m tangent has to be equal to the slope, the same slope as this one. What is the slope of this line? What is m? Yeah, it's just 6, right? So that means the tangent line has to also be, the slope of the tangent line has to also be 6. Does that make sense? How we know this? Now to save time, I'm going to skip the derivative step because we've done that quite a bit. And I don't want to fill up 2 more pages. So let's pretend we already found it. There's f prime. So we were not given a point So use the fact that the slope is 6, tangent slope. So that means that there's some x value that would be equal to 6. What is the x? That x has to be this, right? Because what does the derivative do? Derivative gives you slopes when you plug in a point on the graph. So the derivative will give you the slope of the tangent line that is tangent to a specific point. If I already have the slope, I can work backwards and find the point. That's what we did here. To find the y value, we'd have to plug it in, right? So use the point 6 comma, I'm sorry, 3 comma 9. And the slope and tangent of 6. Let's find the equation of the tangent line that is parallel to this guy. So just use this. Plug in your point. Right? Solve for y. Your equation will be this. Is there any questions about the concepts? I'm going to graph all this so you can visualize it a bit. Okay. So let's just get all this information here. They gave us this random line. And they said, I want the equation of the tangent line that is parallel to this line. So this line basically dictated what the slope of the tangent line is going to be. So using that information, we work backwards to find this point, 3 comma 9. We set the derivative equal to 6, solve for x, plugged in that x into the quadratic, because the f is giving you the points, the derivative is giving you slopes. Okay. Once you have the slope and the point, you will find the tangent line. So this line is tangent to that point and parallel to the red one. That's what we did. We found the equation of the black line here by figuring out the slope of the red line, using the slope to find the point by using the derivative. We worked backwards. Are there any questions on 9? Does that make sense?
That makes sense.
All right. That's 3.1. It's basically it's trying to hammer the idea of what is a derivative? What does a derivative function do for you? Can you find the equations of lines? The specific lines they care about are the tangent lines. What is a tangent line? That is a line that is tangent to a specific point on a function. In a nutshell, that's what we talked about. This, I think we have some time. Let's go ahead and just go through 3.2 real quick. Maybe we can just chill Thursday. I don't know. We'll see. Basic differentiation. Let me give you all the shortcut rules and rates of change. Yeah, you gotta do 5.6. Did we not talk about 5.6? I'll check that in a minute. Number one, the power rule. If you have a power function, in other words, some function that has a power on it, let's call it n, where n is an element of the real numbers, then the derivative will equal n times x to the n minus 1. So instead of doing the limit rules, you can use this shortcut to do a power rule if you have a power function. The constant rule if f of x is equal to c, where c is an element of R, then the derivative will be equal to 0. So if you're doing a derivative of any constant function, it will be equal to 0 because it's not changing. All right, a derivative is also a rate of change, which we'll talk about probably later. Number 3. Here are a bunch of formulas for the trig derivatives. First one, f of x is equal to sine x. So the derivative would be equal to cosine x. Part B, if your function is equal to cosine, the derivative will be negative sine x. If your function is equal to tangent x, the derivative will be equal to negative secant squared x. The f of x is equal to secant x. The derivative will be equal to secant x tangent x. E. If your function is cosecant x, the derivative will be negative cosecant x cotangent x. If your function is cotan, derivative will be negative cosecant squared x. The exponential derivative if f of x is equal to e to the x, then the derivative will just be itself. It doesn't change. Although if it has a constant on top, let's call it k, kx, then the derivative will have kind of like a weird power rule. There'll be k times e to the kx, but only if it's a number. All right, so that's all the rules we're gonna need. Let's see, I guess let's do number 2. Use a graph to estimate the slope of the tangent line. So I recommend, excuse me, is using the shortcut power rule. Because here's the tangent line right there. Oh, all they want is a slope. Okay, yeah. So take a derivative and then plug in x. So given y equal to x to the negative 1/3. Find the slope. Excuse me. Of the tangent line at 1, 1. M10 will be basically the derivative at the number 1. So find the derivative. Let's do it right here. Power rule. The power rule says bring down whatever number's up there as a power. Then subtract 1 from that power. So that'll be negative 1/3 times x to the negative 1/3 minus 1 That's negative 4/3, right? So the derivative at 1 would be this negative 1/3, right? Anyway, that's m tangent. That's your slope of the tangent.
Where'd you get 4/3 from?
The power rule says you bring down whatever power's up there and subtract 1. So negative 1/3 minus 1, that's negative 4/3, right?
Oh, okay, I missed that. Sorry.
No, I'm good. If it doesn't make sense, let me know. Or if I miss something. Okay, but then that's it. That's the slope of the tangent line. Any questions on the first example? That's why they get negative 1/3 here. Take a derivative using the shortcuts, don't use a limit, and then plug in 1. Here is the derivative of a constant, so you should know automatically by rule number 2, I think, it's going to be 0, right? Same thing with 4. Maybe we could do those two. Let's see. Yeah, let's do 5. Find y prime given y equal to 4th root of x. So remember that nth root of x is equal to x to the 1 over n, right? So change the 4th root into this, because this is a power function. So that means you can just take the derivative, which tells you to bring down the power and subtract 1. 1/4 minus 1, negative 3/4, right? I don't think they like negative exponents. So bring that down to the bottom. And that's it. That's why they got this. Any questions on 5? You can see how short the shortcuts are, right? It's way better than the limit rule. All right. Y equal to, this is a quadratic. So power rules. They're all powers. So technically, when you have a number in front, just bring down the 2 in front of it, multiply. Right, so the rule says subtract 1 from the original, 2 minus 1, but bring that 2 down. So 5, there's no power on the x, but it's not written, but we know it's a 1, right? So 1 minus 1, bring down the 1. The last part is a 0. Are there any questions on how we apply the power rule to this part, and there? All right. So at this point, just do your algebra and you're done. So the derivative will be equal to negative 12 x plus 5. That's it. And let's do just two quick examples and we'll call it a night. Just about at a time. You guys cool on 6? All right. Just let me know. So find y prime. So the function they give us on number 7 is, for me at least, 5/3 times. Actually just a pretty part. Okay. So in the formula, we said the derivative of cosine going to be negative sine, right? Derivative of sine is going to be cosine according to the formulas. So just simplify this and you're done. Pi times that is negative pi/3 minus cosine. That's it. Using your formulas, we're done. Is there any questions on number 7? All right, one last question and then we'll take roll. Here we have an exponential and a trig function. So the rule says for the derivative of e to the x is just itself. So it doesn't change. But that 4/7 will just be multiplied times the result. Plus 9 times the derivative of cosine, we said is negative sine. So this will be 4/7 e to the x minus 9 sine x. Whenever you do derivative, you got to do it to every single term in order to get the whole thing. All right, let me take roll.